Okay, as I wanted to try something different, and I thought that I could record what we've learned so far in class. We've talked about the 45, 45, 90 triangle being born, I guess you could say, from a square. And a square has all four sides that are the same. So it's an isosceles triangle when it's broken down into two parts when a diagonal cuts it in half. So this is actually an isosceles right triangle that where I've cut these two corners in half, so now it's 45, 45, and 90. So that's where the 45, 45, 90 rule comes from. We know that when we look at the 45, 45, 90, the legs are x, and the hypotenuse is x square roots of 2. So as I look at it, this would be my leg, and this would be my leg. And always across from the 90 degrees is your hypotenuse. Okay? So I'm going to get rid of the rest of my little square here just so I can create some problems. I thought that what I would do is create some of the easier ones and then go on to the harder ones and show you an example of the kind of problems that might be on your exam. Okay, so I want to scoot this over so it's underneath my 90. The first problem I'm going to do is one where we know the leg. Okay, so if I know the leg, say that this leg was a 3. That means that with my formula that you see on the board, 45, 45, 90, that leg goes in the spot of that 45-degree angle. And then I can also put it into both legs because they mean the same thing. So I have x, and x square roots of 2. And when I do that, so I choose that to be the first leg that I'm talking about. These x's that are on the board, they are exactly alike. So that means this is also 3, and this is 3. So there you have it. One small typical problem that we've been given on the 45, 45, 90s. Now, you can also use Pythagorean theorem to solve these problems just as easy. Remember that Pythagorean theorem is a squared plus b squared equals c squared. So if I'm given a leg, the a and the b are your legs. So I know that they are both alike. I do not know my hypotenuse. I do if I know my special right triangles. So this is 9 plus 9 gives me what? 18 equals c squared. And I have to be able to get rid of that squared, so I'm going to square root both sides. When I square root both sides, I have the square root of 18. That's not simplified, so I have to make sure that I simplify it. So that becomes 9 and 2. Well, 9 has a pair, and that pair is 3 and 3. And remember that the pairs get to go out front, kill one, keep one, and the lonely single guy stays underneath the house, stays underneath the square root sign. So there you have that your hypotenuse is 3 square roots of 2, which is exactly what we found when we used 45, 45, 90. Okay, so there we've talked about Pythagorean theorem and how it's also useful in special right triangles. So we can get rid of this. There, I'll scoop this up. All right, what if I was given a harder problem besides just legs? Besides just this little 3. So if I was given a harder problem, say that I'll stick with the legs for a minute. What if my leg was 4 square roots of 3? All right, that's still a leg. So that means I'm going to come over here, and I've told you guys each time to write this down because this is what's going to help you memorize the formulas. And if you're given a leg, you're given a leg of 4 square roots of 3. So that means that x equals 4 square roots of 3. Each leg is 4 square roots of 3. Okay? So every x on this board equals 4 square roots of 3, including the one that's with the hypotenuse. So with the hypotenuse, you have 4 square roots of 3 because that's my x value, and it's being multiplied times that square roots of 2. So I have to do the same thing when I plug in for my x. We know that with square roots, when you have 2 square roots that are being multiplied, you can put the numbers under the same house. So my answer for my hypotenuse would be 4 square roots of 6. So remember that each one of these x's equal the same thing. So if you have an x that equals 4 square roots of 3, you could just substitute it in everywhere you have an x. All right, let's try possibly, how about a hypotenuse problem where it actually has the square root of 2 plugged onto the end of it. So if I do a hypotenuse problem and I say that my hypotenuse is 6 square roots of 2. So as you notice, that square root of 2 and this square root of 2 are the same. If they're the same and you can actually see it, then all you have to do is pull that 6 off of there because that is your x value, as long as both of those are the square root of 2. So that means both of my legs are 6. Okay, that's the easy hypotenuse problem, right? So then let's try one that's a little more difficult. So how about, oh, I don't know, 4, oh, we already did 4. How about 2 square roots of 3? Now, when you look at this, that square root of 2 and that square root of 3, they sure are not alike, so you cannot pull that 2 off of there and think that it's an x. This is the one where you have to do a little bit of work. So I know that the square root, x times the square root of 2 is equal to whatever is in my hypotenuse spot. That is 2 square roots of 3. So I can set them equal to each other and solve for x. In order to solve for x, I have to divide by the square root of 2, and then x is by itself. So whatever I get on the right-hand side, that is my x value. All right, well, you look at it, that square root of 2 cannot be in the denominator. We've talked about this for weeks now, and if it's in the denominator, it has to be rationalized to get gone. We no longer want radicals in the denominator. So back to the same thing, multiply across the top and multiply across the bottom. So 2 times the square root of 3 times the square root of 2 is the square root of 6. Remember, it can go under the same house. Square root of 2 times the square root of 2 is the square root of 4. That's a perfect square, so it's just 2. 2 goes on the bottom. Remember, when you multiply, when we do this rationalizing thing where we multiply the square root of 2 over the square root of 2, you're creating that perfect square down at the bottom. That's why your number will always be just the number that's underneath the square root sign. All right, so I've got this problem, 2 square roots of 6 divided by 2. Now I have to simplify my problem because it's not quite finished. Both of those 2 live on the outside of square roots, so I can simplify those and reduce those to 1 over 1. So when I do that, my final answer for my legs are the square root of 6. Each one of these is the square root of 6. And there you have an example of every problem you could have on a 45, 45, 90 problem. Now remember, just like we did the Pythagorean theorem with the leg, you can do the Pythagorean theorem with the hypotenuse. It's a little more detailed, a little more work, but I'll show it to you. We'll see if we get the same answers. I'm going to leave those answers right up there. And now we'll go ahead and see if we can't solve it. So if I'm doing the Pythagorean theorem, I don't know what my legs are because that's what I had to solve for, right? So I have c in my hypotenuse, and it was 2 square roots of 3 squared. All right, how many x's do I have? How many x squareds do I have? I have 2 of them. So 2x squared is equal to, remember when you have an exponent on the outside, it has to go to each of these things. So 2 squared is 4. The square root of 3 squared is 3. Those two things are inverses of each other. So now I've got 2x squared is equal to 12. I have to divide by 2. When I divide by 2, I get x squared is equal to 6. Well, I can't have a squared on my x, so I have to square root both sides. When I do that, I get a final answer of x is equal to the square root of 6, which is exactly what we got when we used our special right triangles. See you later.